at the joint curve, we will find that we have obtained a ellipse which is having major axis of 100 mm and minor axis of 70 mm. So this is how we can draw using the arc of circle method. Now we will have next problem, please. We will look at our next problem. The next problem is about an involute of square of side 25 mm. Now when we talk about the involute, it's a curve which can be traced if a polygon has been converted into the inelastic spring, and the curve traced by it is called involute. Over here we need to draw involute of a square. We will see how we can draw the involute of a square. What I am going to do, first of all, I need to draw the square of the 25 mm side. The middle portion I am drawing the 25 mm side square. Side square I am drawing. First of all the sides should be perpendicular, or else inaccuracy will shown immediately. Name it as ABCD. Name it as A, B, C and D. Let's extend the lines. Extend line AD, CD, BC, and last AB. I have extended those lines. Extension means stretching that lines to the next point. Now we'll use the compass. We'll take AB as radius. We'll take AB as radius, A as center, draw a arc. AB as center, A as radius, and draw a arc. Now let's name this point as point number P1. Point number P1. DP1 as radius and D as center now. DP1 as radius and D as center. Like this. DP1 as radius, D as center. Like this. We have got point number P2. We have got point number P2. CP2 as radius. Now the third would be CP2 as radius, CP2 as radius and C as center. Like this. CP2 as radius, C as center. We will draw an arc. Like this. we have got point number P3. Now BP3, BP3, BP3 as radius, B as center, mark an arc. We have obtained point number P4 and our involute is done. This is the curve traced by this. If we have converted this line, this AB line has been converted into spring, it looks like this. Then DAB converted into string, it will trace curve like this. AB, AD and CD, all three of them converted into the string, then they will trace path like this, and the whole square has been opened and converted like this, then the path would be traced like that. Now let's repeat this procedure, how we can draw involute for any of the object. Over here we need to draw involute for the square. Now when we are talking about the square is having all side equal. Over here we have been having side of 25 mm each. Be proper to have a proper perpendicular sides only. I have drawn ABCD square. I have extended line AD, CD, BC and AB. All the lines have been extended. Now we will start from here. Point A as center, AB as radius and arc. We have got point number P1. A as center, AB as radius, arc. We have got point number P1. Next step would be D as center, DP1 as radius, D as center, DP1 as radius. Draw a arc. We have got point number P2. Now C as center, CP2 as radius, C as center, CP2 as radius. Draw a arc. We have got point number P3. B as center, BP3 as radius and draw an arc. We have got point number P4. This is how we can trace a whole involute for any of the polygon. We will have a look at our next question. Our next question is, we need to draw a parabola by rectangle method having base and axis 100 mm and 80 mm respectively. In this portion itself, we have seen the terminology of the ellipse. We can say that ellipse, parabola and hyperbola, cycloid and epicycloid are amongst the engineering curves. Now if we look at this parabola, for this also we need to understand the terminology of the parabola first of all. What is parabola? If we will see in this with some graphical representation. Let's say that one man is standing over here. One man is standing over here and in his hand he is having a ball. He throws the ball towards the another man. This curve traced is called This curve is called as parabola. Now if you notice it properly, there are two things happening. The first, distance traveled, how long it went, and from this person to this person, what was the height of parabola. These two things would be very important: distance traveled and height. I'll give you one more example of the same only. This, we are having a headlight. We are having a headlight like this, parabola. We are having a bulb kind of circular plate over like this over here, bulb, sun rays and all these rays facing this parabola, which causes focused light. We will have a focused light. So parabola used for headlight, solar mirror. It concentrates the rays, so that's why in solar mirror also parabolas been used. Now we understand what is parabola, how parabola looks like. Two things would be very important in this parabola. First would be distance traveled and another would be height. Now we will look at our problem. What is the problem? We are having a base of 100 mm and height of 80 mm. Base 100 mm, x is 80 mm. It's same altogether. Either it is base or distance traveled. Base or distance traveled is equal to 100 mm. This has been given. On another side, x is or height is altogether same. It's been given as 80 mm and we need to draw using rectangle method. Three datas have been given. Now we will draw this parabola. What we are going to do first of all, base has been given, so I will draw this base. It's 100 mm. Long line. Let's name it as AB. I'll take midpoint of it. Perpendicular to it, as it is called rectangle, 100 by 80 rectangle would be made. Perpendicular to it, I'll draw height of the parabola, that's 80 mm on both the side, from point number A and from point number B, both. Like this, we have got this. This is 100 and this is 80. Now let's name it as AC and BD, means ABCD. Divide AC and BD into 5 equal parts, which means that 16 mm each. each. BD would be same altogether, 60 mm each. Now we need to divide this OA and OB line also into 5 equal parts. It would be 10 mm each. Draw perpendicular line. From this point, O dash, join these lines 1, 2, 3 and 4. On another side as well, similarly 1, 2, 3 and 4. We have got intersection points 1, 2, 3, 4. 1, 2, 3 and 4. We will join it either with the French curve or freehand, and this is how we can get our desired parabola shape, which is having base of 100 mm and height of 80 mm. So that is the end of this video lecture of paper solution January 2000.